Negative integers as exponents.
Wait a minute. If the exponent is negative, doesn't that mean the number's negative?
No, it just means it's really, really, really small.
Thanks, guys. That was a great introduction. All right, so we are going to do negative integers as exponents. So we're going to start by following the pattern. 2 to the third power is 2 times 2 times 2, which is 8. 2 to the second power is 2 times 2, which is 4. 2 to the first power is 2, which is just 2. So if you follow this pattern, you can see, well, what happens? How does 8 become a 4? You divide by 2. If 4 becomes a 2, how do you get there? You divide by 2. Now, another way of dividing by 2 is actually, you could say, multiply by a half. What's half of 8? 4. What's half of 4? 2. What is then half of 2? Half of 2 is 1. So wait a minute. That means when I get 2 to the 0, I get 1? Crazy, as if. So why this works is because there's a secret agent, number 1, and when you have 2 times 2 times 2 equals 8, you could also say it's 1 times all of this equals 8, and 1 times all of this equals 4, and 1 times all of this equals 2. So 2 to the 0 is actually equal to 1. Now, if I keep following this pattern into the negative exponents, Sage was right. It doesn't equal a negative number. It just equals a really small number. So if I take 1 and I multiply by a half or divide by 2 and follow this pattern, what's half of 1? A half. So when I have 2 to the negative 1, that is actually equal to 1 over 2. Well, let's keep going with this pattern. If I again multiply by a half, I get 1/4. So when I have 2 to the negative 2, that's actually equal to 1 over 2 times 2. And I could keep going with this pattern, and this would be 1 over 2 times 2 times 2. Well, let's see. What is 1/2 of 1/4? It is. It's 1/8. Okay? Follow the pattern. Now, we have some rules. We've got to remember our rules. So as you saw this pattern, you can see that when you get to an exponent of 0, the answer is 1. So a to the 0 power, in fact, any number raised to the 0 power, equals 1. Now what about a to the negative n? Well, if we follow the pattern, when we have 2 to the negative first power, it's actually equal to 1 over 2. And if I have 2 to the negative second power, it's equal to 1 over 4, which is actually the same as 1 over 2 squared. And 2 to the negative third is actually equal to 1 over 8, which is 1 over 2 to the third. So when you have a to the negative n, this is the same as 1 over a to the positive n. Awesome. So wait a minute, what if I have it in the down here? Well, what you should be noticing is 2 1/2, 4 1/4, 8 1/8 are actually reciprocals of each other. The only difference is here it's a positive exponent, here it's a negative. So when you have 1 over a to the negative n, we are going to actually rewrite that as a to the positive n. If you'd like, we could put it over 1, but it's not really necessary. We could just call it a to the nth power. Now, what about a over b to the negative n? Well, we just talked about how it kind of acts like a reciprocal. So that's actually what happens, is we change a over b to the negative n to b over a, but instead of a negative exponent, now we have a positive exponent. Let's try some examples. Negative 7 to the 0 power. Well, wait a minute. Anything raised to the 0 power equals 1. So negative 7, even because it's in a parentheses, raised to the 0 power will equal 1. What about 7 to the negative 2? Well, if we use this rule, this is the same as 1 over 7, but instead of a negative exponent, we have a positive exponent. As if, totally. All right, what about 1 over negative 3 to the negative 4th? Well, this is this rule. And this will then go from the denominator up to the numerator. And the exponent will go from a negative to a positive. So when the number moves from the numerator to the denominator or the other way around, the exponent goes from negative to positive. So we have negative 3 to the 4th power over 1 if you want. But if we want to solve this, we would do negative 3 times negative 3, 9, times negative 3 is negative 27 times negative 3, which will actually equal a positive 81. Ooh, what is this one? 1 over 49. Sorry, went a little backwards. Hee. All right, last problem, 1 over 3 to the negative 2. So what we can do is we can do the reciprocal. What's the reciprocal of 1 over 3? 3 over 1. And then you have the negative exponent, so you turn it into a positive exponent. So this is actually just 3 squared. 3 squared is 3 times 3. 3 times 3 is 9.